Hi there, welcome to edupediaworld.com. You're watching the videos on lucid geometry. Now in this video we'll discuss the further extension of fifth postulate of lucid geometry. As we have discussed in the previous video also, uh, we discussed how the fifth postulate is important in geometrical concepts, but here we will discuss the further extension of fifth postulate. So watch that section very carefully because it's very important from the exam point of view. Then we'll discuss like some of the extra questions which are generally seen in examinations, so you have to watch this video very carefully. So let's get started with the first topic, which is fifth postulate of lucid geometry. Now it's written equivalent version of fifth postulates of lucid geometry. Now in the previous video, for the fifth postulate, we have seen that it defines that if the two lines like this, these are the lines, and there is another line lying on these two lines, and if they make an interior angle like angle 1 and angle 2 on the same side, either on the right or either on the left, and if angle 1 plus angle 2 is less than 180, then these line L and M will intersect. They will intersect. Now in this section we'll discuss the equivalent version of this postulate. Means we'll discuss the equivalent version of this definition only. So it says that for every line L and for every point P not lying on line L, means the point P is not lying on the line L, there exists a unique line M passing through P, that if this point P is not lying on line L, suppose this is a line L and there is a point P and the point P is not lying on the line L, there exists a unique line M, we can say, which passes through point P and parallel to L, means this line will be parallel to L. Now parallel to L means that the distance between these two lines must always be consistent or should be fixed, means it should be consistent. Or we can say the distance between the two lines P and L should always be same, which is the another version of fifth postulates. So how it can be further extended, like see, in the previous version of fifth postulate of lucid geometry, we discussed that if these two angles, the sum of these two angles, angle 1 and angle 2, is less than 180, then the line P and M will intersect. Now suppose there are two parallel lines like this, line M and line L, and if there is a line, another line lying on these two lines, then these are the two angle 1 and angle 2. Now if the line M and L are parallel, means the distance between the line M and L is fixed, so they will never meet. So this means these two lines are parallel. Now the angle 1 plus angle 2 should be equals to 180 degree. So this is the equivalent version of the fifth postulate. So this result can also be stated in the following form: two distinct intersecting lines cannot be parallel to the same line. Means if the two lines are intersecting, like these line L and M, if we extend these lines like this, so they will definitely intersect at a point. So these lines cannot be parallel. So this is the equivalent version of the fifth postulate. So let's move on further. We'll discuss one example related to this fifth postulate. Now the example says that consider the following statement: there exists a pair of straight lines that are everywhere equidistant from one another. Means there exists a pair of line like this. Suppose this is a line and another line is like this. They are equidistant, mean the distance between them is same, like this, the distance is always the same. And is this statement a direct consequence of usage fifth postulate? Yes, you can say that this is a direct consequence. Why? As we have discussed in the previous slide also, that if these two lines like line L and line M have equal distance between them, equal distance between them, then the lines are parallel, or lines will never intersect. So which explains the fifth postulate. So that is the explanation of the questions. Now let's move on to the question number 1. These type of questions are generally seen in examination, so you have to watch this section very carefully. Now the first question says, which of the following statements are true or false? Give reasons for your answers. Now we have to state which of the following statements are true and false, and we have to justify each answer. Now the first question says, only one line can pass through a single point. Only one line can pass through a single point. Now you can see clearly that this statement is false, since if we draw a point, if we have a point like this, we can draw n number of lines passing through this point, like this, like this, like this, like this. We can have infinite lines. So from visual representation you can clearly see that this statement is false. Now the second statement is, there are an infinite number of lines which pass through two distinct points. Now suppose we have two distinct points like this, as according to the postulate of, we have discussed Euclid postulate, or we can say the axiom number 5.1. You can refer the book, that if we have a two distinct points, then there is only one unique line that can pass through these two points. So again this statement is clearly a false. Why? Because it's clearly mentioning that there can be infinite number of lines which pass through two distinct points. So this statement is also false. Now the third statement says, a terminated line can be produced indefinitely on both sides. Now postulate 2, as we have discussed, postulates 2 or second postulate of lucid geometry explained about a terminated line. So terminated line is line which has a fixed length, or in current scenario we say it like as a line segment. Now line segment. Now if a terminated line can be produced indefinitely on the both sides, we can produce that terminated line indefinitely on the both sides. So the statement is true. If two circles are equal, then their radii are equal. Means suppose these are the two circles. Now if it says that if two circles are equal, then radii are equal, means their radius should be equal. Now if suppose it has a radius of 3 centimeter and it also has a radius of 3 centimeter, then if both the radius of the circles are same, then only we can have equal circle with equal circumference and diameter. And if we superimpose, like we put one circle over another circle, then we'll get a exact same circle. So this statement is true. In the figure 5.9, figure below, if this figure is this, if AB equals to PQ, if line AB is equals to PQ and PQ, this line is equals to XY, then this line is equals to XY. Means if AB equals to PQ and PQ equals to XY, then we have to prove AB equals to XY. Now according to postulate fifth axiom of lucid geometry says that if two things are coincides, they are equal to the each another. Means suppose if we have a line like this, AB and point C. Now if AC is equals to BC, or it can be written like this, like AB can be written as AC plus BC. Means if these two points and these 2 points coincide on the same thing, they are equal to one another. So similarly we can say that if AB equals to PQ and PQ equals to XY, so according to axiom 5 of Lucid, we can say AB is equals to XY. So this is how we can solve these type of questions. So let's move on to the next question, question number 2. Given a definition for each of the following terms, are these other terms that need to be defined first? What are they and how might you define them? Means you have to define each and every term in the term of geometry. Now, the first question is parallel lines. The parallel lines means, so the lines which have equal distance between them, means they have fixed distance. So these are parallel lines. Now, perpendicular lines. Perpendicular lines are those lines which make 90-degree angle with one another. And we have studied in a postulate that each and every 90-degree angle, whether like this, or you can say if we make a 90-degree angle like this, they are equal. So that defines the perpendicular lines. Now line segment. According to the postulate second, a terminated line, a line which has a fixed length, is also defined as a line segment or terminated line according to postulate 2. Now radius of a circle. Now the radius of a circle is a point, like we can say, suppose we have a circle like this, and this is the radius, this is the center of a circle, and this is the radius. Now so the radius of a circle can be defined, it is a distance from center of circle to the circumference of circle. Now square we can define is a four-sided figure. It's a four-sided figure. Each line makes 90-degree angle with each other, and all lines are equal, or terminated lines are equal. So this is how we can define each and everything. Now let's move on to the question number 3. Now the question number 3 says, consider two postulates given below. Given the first postulate is, given any two distinct points A and B, there exists a third point C which is in between A and B. Means given 2 points A and B, there exists a third point C in between A and B. So, and the second, this is a first postulate, and the second postulate says there exists at least 3 points that are not in the same line. Suppose this is the first point, this is a second point, and this is a third point. So these are not in the same line. We can mark this like A, B and C. Now we have to answer, do these postulates contain any undefined terms? Now there are several undefined terms. We can say that point is a part, or a point has a dimensions which are never defined, and a line which can be extended to indefinitely to any length. So there are a lot of in undefined terms which we can actually list it, as we have discussed in the previous videos also. So that is a problem. And now, are these postulates consistent? Yes, these postulates are consistent. Yes, these postulates we can say they are consistent because they deal with two different situations. Means now in this first postulate we have 3 points, but they are in the same line. In the second postulate we have also at least 3 points, but they are not in the same line. So these two conditions actually can prevail, or we can assume it as a universal truth also. So that's why these postulates are consistent. Now, do they follow Lucid's postulate? If first, we'll discuss each and every postulate. First says that given 2 points A and B, there is a C point line on line in between them. So, and the second point says that there exists a point, another third point, or we have at least 3 points which do not lie on a same line. So we can say that these two postulates do not follow Lucid's postulates. So, however, but we can say that however they follow axiom 5.1. So this is how we can solve the question number 3. Now let's solve the question number 4. Now if a point C lies between 2 points A and B such that AC equals to BC, then we have to prove that AC equals to half of AB. We have to explain by drawing an example. Suppose we have 2 points AB and there exists a point C like this, such that this line AC is equals to AB. Then we have to prove that AC equals to half of AB. Now let's see how we can prove that. First, we are given that AC equals to AB. Then what we can do is we can write like this: AC plus AC equals to AB plus AC. Means what we are doing is we are adding equals on both sides. Means we are adding AC and AC on both sides. Now what we get is AC plus AC is 2AC. Now and given to be equals to BC, we can write BC over here. BC. Now BC plus AC will become AB. So AC can be written as half of AB. So this is how we can prove this question. Now let's move on to the next question, which is also a last question of the video. Question number 5. So question number 5 says that if AC equals to BD, then we have to prove that AB equals to CD. Means we have to prove that AC equals to BD. So how we can prove that? First, it's given AC equals to BD. Now AC can be written as AB plus BC. Why? Because point B is in between AC. Now let's discuss the question number 4 of the video. Now the question says if a point C lies between 2 points A and B such that AC equals to BC, then we have to prove that AC equals to half of AB, and we have to explain each and everything by drawing a figure. Now suppose this is a line AB and this is a point C. Now if a point C lies in between the points 2 points A and B such that AC equals to BC, means this line is equals to this line, then we have to prove that AC is half of AB. Now as we have discussed in the postulate that if the same things are equal to, if equals are equals to the same thing, then they are equals to one each another. Means if this side is equals to this side, then these two sides are equal to each another. Or we can write like this: if AC is equals to BC, means if this is AC, this is BC. So AC will be half of AB, or we can say AB will be 2 times of AC. Why? Because these two lines are equal, but when we combine each of them, it makes the complete line AB. So this is how we can explain through the figure. But let's see how we can prove it mathematically. Now we are given AC equals to BC. Now if we add AC on both sides, we get AC plus AC equals to AC plus BC. We can say right like this: equals are added on both sides. So this becomes 2AC, and AC plus BC will become AB. So AC is half of AB. So this is how we can prove this type of question. Now let's move on to the next question, the question number 5. The question says that if AC equals to BD, then we have to prove that AB is equals to CD. So it's very interesting question. So watch the question very carefully. So we are given AC equals to BD. Then we can write AC as AB plus BC. Why? Because AC is made up of, this is line, so AC can be written as AB plus BC. Why? Because point B lies in between A and C. Again, we can write BD as BC plus CD. It can be written as BC plus CD. Why? Because C is a point C lies in between B and D. So we can mark this as 1, we can mark this equation as 2, we can mark this equation as 3. Then we can say like that, we substitute 2 and 3 in 1. So we get AC can be written as AB plus BC, and BD can be written as BC plus CD. So this and this will cancel out, so we'll get AB equals to CD, so which we wanted to prove that. So this is how we can solve these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day ahead.